This is our AS induction work, the fourth lesson. I would say crossover between GCSE and AS level, but this is very much a GCSE topic. Simultaneous equations, so any simultaneous equations video would help. We'll start with a recap of what we did before, so push pause while you try that. All the different things about a straight line. Here it is, it's going along 2 and it's going up 5, isn't it? So the gradient is 5 over 2. The equation is y take away the y number equals gradient x take away the x number. We could rearrange that to make it 2y take away 24 equals 25x minus 25. Sorry, not 25x, 5x minus 25. Find the length of this. Well, the length of this is the square root of 2 squared and 5 squared. So that's the square root of 29. The midpoint's halfway along and halfway up. Halfway between 3 and 5 is 4. Halfway between 7 and 12, well, that's 19. 19 divided by 2. And find the gradient of the perpendicular. A perpendicular to it, well, our one had a gradient of 5 over 2, so this one's got a gradient of minus 2/5. And the extension is to find the gradient of the perpendicular bisector. Everyone will have to do that eventually. It just gives the faster ones a chance to do something extra. So our work today is to try and find out these different ways of solving simultaneous equations. And simultaneous equations are used a lot to try and find out where two lines meet. I want to find out where the straight line y equals 3x add 1 meets the horizontal line y equals 3x. So here they are. Here's y equals 3x add 1, and here's the y equals 3 going across there. And we can see that they're going to meet there. So what that looks, there's 1, isn't it? It's about what, 2/3-ish? I don't know. Well, let's do it algebraically. Algebraically, what we do is we put them equal to each other. So I've got y equals 3, I'm putting that there. Look, if you take away the 1 from both sides and divide by 3, we do indeed get x is 2/3 where they meet. So that coordinate that they met was actually 2/3 3. You could check that by putting the 2/3 in there. 2/3 times by 3 is 2. 2 add 1 makes 3. That's where they meet. Well, what about if we had two lines, straight lines, but not horizontal? So here's y equals 3x add 1, and let's put on top of that y equals 2x add a half. So they're meeting down here somewhere. Looks like it's a negative number, maybe minus a half. Let's try it algebraically. Let's take away 2 x's from both sides. Let's take away 1 from both sides. And indeed, they did meet when x is equal to a half. Minus a half, x is equal to minus half. Now we can find out what the y number is by throwing minus a half into that. So we've got y equals minus a half from that. Or we could try it the other way. 2 lots of minus a half, add a half. That's minus 1, add a. So the coordinates where they met was actually minus a half, just as we saw on the picture. You try some of those yourself, please. Can you put these two equal to each other and then try and solve the equation that you get? These equations really are sort of Key Stage 3, very lower school equations. If you are having trouble with this, you do need to talk to your teacher about solving simple equations like this. The second method is then to, rather than them being y, both of them being y equals, this time the y is included somewhere inside it. But the other one can be made to make y equals. This one actually says y equals. They won't always be quite as obvious as this. And our method is to take this and drop it in there. So instead of writing x add y equals 10, we're actually going to rub out that y and put what it's equal to. X add 3. And now look at this algebra. X and x is 2 x's. Add 3 is 10. Take away the 3 from both sides. Divide by 2. So x is 7 over 2, or 3.5. Now if x is 3.5 or 7 over 2, then y is just 3 times bigger than that, is add 3 to that. So we're adding 3 to that, must be 13 halves. And we could check that, because if you add those two together, you get 10. Well, look, 7 and 13 is 20, 20 halves, 20 over 2. Yes, it is 10, it does work. So your job now is to try and see, oh no, I've got another example first. The other example here is because this one doesn't immediately say y equals. You need to tidy it up yourself before you can do it. So y equals 2x add 11 by adding the 11 to both sides. And now let's take that algebra and drop it in where the y is there. So I've got 4 lots of y, and y was this, minus 3x equals 29. Still we are at sort of year 7, 8 algebraic manipulation here. Times out the bracket, take away 3x's equals 29. I'll take the 44 from both sides. 29 take away 44 is minus 15. And 8x take away 3x is 5x's. Divide by 5 makes minus 3. If x is equal to minus 3, well, I can find out what y is, because y is 2 lots of minus 3 add 11, which is 5. Should we go back and check it? So 4 times the y number is 20, minus 3 lots of that, so minus 15, no, minus 9 is 20, minus 9 is 29. It does indeed work. Checking it back in the other one is always a useful check. Here's some for you to try. Drop one into the other and see if you can cope with all the algebra and the numbers there. Push pause because the answers are appearing. Now, there's each of the answers to those ones. Method 3 of solving is the one which you probably did the most, elimination method. You've got 2 equations and you either add or take them together to see what happens. This one here, we're going to add the equations together. 2x's add x makes 3x's. Y add minus y cancels out. They are eliminated. That's the point of adding them together. 13 and 2 makes 15. And so x is 5. Stick the 5 back in here and it tells you that y must be 3. Check it in the top one. 2 5s are 10, add the 3, makes 13. It isn't always add them together. Sometimes, of course, it's take them away. If you added them together, they wouldn't be eliminated. But if you take these away, the y's disappear. And we're going to get x equals 4 and find out that y, what's y? Is it y minus 5 there? I'm only guessing. There's an exercise of those to do, although I usually just get people to select some. Do try one of these ones with the 2's in, though. Have a go at some of those. That's copied from my old Year 9 teaching of simultaneous equations. And we then went on to these ones here, and we say, look, the y numbers are different here, so we're actually going to have to times this one all by 3 before we can do the work with it. And now we will subtract those 2 equations, giving us 2x equals 12 and x equals 6. Drop the 6 back in. We can got a choice of 3 of them now. Probably best to drop it back in that one there because they've got the lowest numbers. So we got 3x's add y is 20, or 3 times x is 18, and so y must be 2. Check it in the other one. So 66 from that bit there, and 3 times 2 makes 6. Yes, that's 72. We know we've got it right. And the last bit would be if the y numbers, we couldn't just times them. We have to think, what do 2 and 3 both go into? And of course the answer is 6. So we times the top one by 3 and the bottom one by 2. The bottom one gets times by 2 as well. And we're subtracting this time. Now we don't, I mean, if I go that way, I'm going to get loads of negatives. So I'm actually going to go that way. I'm going to do 14 take away 9 is 5. I'm going to do 20 take away 15 is 5. And so x is 1. And then you can work back to find out what y is. So there's 8 of those to try and do. That's a slightly more interesting, but still copied off my Year 9 teaching. No great A-level stuff here, just things we need to do. Try those as quick as you can. Push pause, because here's all the answers to each of those there in green. The X number answer and the Y number answer for each of those. Some A-level context ones are on page 16 and 17 of your Core 1 book. That's exercise D. And that's it. We will stop there. I think in the rest of my lesson I'm going to start looking at some surds, but I'll stop the video there